SwayamPrabha. Digital India. Educated India.
Hello, I'll continue the discussion, introduction and classification of turbo machines. Contents of the lecture are application of gas turbines. Here I'll discuss on turbojet, turbofan and turboprop engine. I've also cited different examples illustrating constructions of different machines. I'll start from high bypass turbofan engine, then multi-stage compressor, centrifugal compressor, Kaplan turbine, Francis turbine, and Penton wheel. I'll initiate the discussion with applications of gas turbines. Gas turbines are used in stationary power generation unit and jet engines. The Brayton cycle is the operating cycle for a gas turbine, and the closed cycle is used for power generation unit, while open cycle is used for jet engines. Let me discuss further. I have discussed here the schematic of an open cycle, where this is the compressors and combustion chamber and the turbines. So air is sucked by the compressor and it compresses here and then pushed to the combustion chamber, where combustion occurs at constant pressure, and then it is being expanded in turbine, producing work output, and that work output is sufficient to run the compressors, and the rest part of the compressed air is exhausted through a nozzle to produce jet in case of a jet engine, or in case of a power plant or power generation unit, it is fully expanded in the turbine, and the part of the energy produced is extracted to run the compressor, and the remaining part is used to run the generator to produce power. These Brayton cycles you have gone through in your thermodynamic classes. Still, I have shown here the TS diagram. In the later part of the course, I'll tell you how we enhance the efficiency of the cycles and the power output. Here I have shown in TS diagram 1-2 is the ideal compression process, and 1-2- is the actual compressors, considering some isentropic efficiency of the compressors. Similarly, 3-4 is the ideal expansion, and 3-4- is the actual expansions. And 2-, 3- is equal to the combustions process occurring in the combustion chamber. And if you calculate the efficiency of the cycle, then it can be expressed that eta is equal to 1 minus 1 over Rp to the power gamma minus 1 by gamma, where Rp is nothing but pressure ratio P2 by P1. So as the pressure ratio of the cycle is increased, its efficiency increases. However, for steam power plant, the Rankine cycle closely describes the process found in thermal power plant, where a pump is used to compress water and high pressurized water is fed to the boiler where it is heated and steam is produced, and that supersaturated steam is expanded by the turbine to produce the work output to run the generator, and it is again condensed, and that condensed water is again pumped to complete again fed to the boiler to complete the cycle. I have shown here in the TS diagram, temperature entropy diagram, where 1, 2 is the pump work, 2, 3 is the heat addition in the boiler, 3, 4 is the expansion process that occurs in turbine producing power output, and 4, 1 is the heat rejection by the condensers to complete the cycle. Now I'll discuss about jet engines. The turbojet, turbofan, and turboprop engines play a dominant role in aero industries. The modern trend of development of aero engine is raising its propulsive and thermal efficiency. Furthermore, the requirement of aero engines for civil aviation are fuel efficiency and low noise level, whereas the combat aircraft for defense application calls for high performance, thrust, speed, and extreme maneuvers. Thus, the requirement for civil application and that of the defense are completely different, and thus the design would be different. Apart from aero engines, gas turbine as a propulsive device is used in ships, truck, and trains. Let me explain now the jet engine with the help of some schematic diagram. So first I have discussed about the turbojet and turboprop engine. This is the schematic of turbojet. The turbojet sucks air from atmosphere, and that air is compressed in a series of multi-stage compressors. And then the compressed air is pushed to the combustion chamber, where combustion occurs, and then high pressure and temperature air is partly expanded in a turbine, and the product power produced by the turbine is sufficient enough to run the compressor, and the remaining pressurized gas is expanded by a nozzle to produce thrust. A turbojet engine is used in defense application, and it is characterized by its high propulsive thrust and speed. Now here is the turboprop engine. which hold a propeller in front of the engines, and it is characterized by its high propulsive efficiency and low specific fuel consumption. So air is again sucked by multi-stage compressor, which compresses air. Combustions occur in the combustion chamber, and then pressurized and high temperature gas is fully expanded in a turbine to produce power output, and that power output would be sufficient to run the propeller and the compressors. Propeller rotates at slower speeds, and the pressure difference between the propeller, that is pressure rise in the propeller, is pressure gradient that develop is relatively small, which is sufficient enough to produce thrust. Now I'll come to turbofan engine. Turbofan is a combination of turboprop and turbojet engine. So it's having a large font in front of the engine, as you can see here, and the air is divided into two streams. One stream is going outside the engine, and other is passing through the series of compressors. And air being compressed by two stages. One is called high pressure stage and the low pressure stage, and similarly turbine. So what I like to tell you, in other words, that air is bypassed. So one half of the air goes outside the engine, and other half is passing through the multi-stages compressors and then pushed to combustion chamber. Combustions occur, and it's being expanded in the turbine. There are also the two stage. One is called high pressure stage and the low pressure stage. Low pressure, generally the shaft, low pressure shaft, is connected to the fan, and then the remaining part of the gas is expanded through the nozzle to produce thrust. So here part of the thrust is come from the exhaust jet and part from the large fan. So that's why it's a combination of turboprop and turbojet engine. What we have got? The design innovation of high bypass turbofan engine is huge, considering the fact it enhances efficiency and it reduces noise level. Thus, a turbofan engine is characterized by its low specific fuel consumption and low noise level. By these three figures, I have explained the characteristics of turboprop, turbofan, and turbojet engines. Look, this is the propulsive efficiency versus speed. At low speed, turboprop is efficient, whereas turbojet engine is efficient at higher speed, and turbofan lies between the turboprop and turbojet. This figure illustrates thrust versus speeds. At lower speed, turboprop gives maximum thrust, whereas turbojet performance is very poor. After certain speeds, turboprop cannot be used because of its thrust decreases dramatically with speeds. So after a certain speed, turbojet is the only option, and its third increases with the speed. And definitely turbofan, being a combination of turbojet and turbopop, lie between the two. Here I have shown the altitude and the Mach number. You see, turbopop lies in the range of 0.3, 0.4, maximum 0.5 Mach number. After 0.6, turbofan takes over, and turbofans generally fly at about a altitude of 10,000 meters, where turbopop flies at an altitude of 5,000 meters. You see, turbojets is active at a very high Mach number of Mach 2 and beyond. This is very efficient at this range. And turbojet flies at an altitude of 20,000 meters. So by this figure, you can appreciate the characteristics of three machines and how when they are used particularly. When you fly at a lower speeds, particularly that's lower craft, we use turbopop, and turbofan are used generally for a large aircraft carrying about more than 200 passengers. Further, I have stated here that in aero engines you will find most sophisticated applications of turbo machines, and to illustrate further, I have taken a cut section of a high bypass turbofan engine produced by Rolls-Royce, and the engine is designated by PW4000 fan engine, and is characterized by fan diameter of 94-inch, thrust 52,000 to 62,000 pound, bypass ratio 4.8 to 5, overall pressure ratio is 27.5 to 32.3. There are some aircrafts which are powered by the engine, and they are Boeing 747-400 and Airbus A300-610. Thus you can appreciate the most modern aircraft is powered by the engine. To explain the construction, you will find a large fan here. Please note that the fan is highly twisted, and there are series of multi-stage compressors started from low pressure stage to high pressure stage, and you can find out the annulus area also decreases because of the compression of air, and then push to combustion chamber where combustions occur, and then highly compressed and high temperature gas is expanded in a turbine, first in a high pressure turbine, then a low pressure turbine. You can appreciate how annulus area and the blade height changes in low pressure turbine because of expansion of gas, and the rest is expanded through a nozzle to produce thrust. So as I have told earlier, the thrust is produced here by the combination of the exhaust jet and the fan. And look, the low pressure turbine is connected to a shaft, and there is a coaxial shaft actually. This is the multi-spool machines, and the shaft which connects the low pressure turbine stage is connected to the fan and the low pressure compressors, and the high pressure turbine stage is connected to the high pressure compressors. So I trust you have appreciated the complications and you have appreciated how the functionality of the engines. And now I'd like to tell you this combustion chamber, turbine, compression and fan has to match. And if time permits, I'll explain you matching of all components. And this engines hang from the wing. So I have shown a picture just to tell you, you see this large engine hangs from the wing to produce the required thrust for the big craft. Here I have shown you a 9-stage compression blade. Obviously, there will be a rotor followed by stator blades. And the orientation of rotor and stator blades are different. I'll explain you later. Now you can find out this towards the entry, the height of the blade and exit at height of the blade are different because of the compression of air. And you have also appreciated that blades are aerofoil structures. Let's take another example, which is the impeller for centrifugal compression. The construct is completely different. This frontal part is called the eye of the impeller, and the air is being sucked axially and then it is thrown out radially. And hope you have appreciated the construction of impeller here is completely different from the axial impellers. And another picture I have shown for a Pelton wheel, which is a primitive machines. Here a water jet is being produced by the nozzle, and the water jet is deflected by the impeller passage by about 165 degrees, producing thrust. And hope you have appreciated, as the water is being deflected by the impeller, the pressure remains constant. That's why it's called an impulse turbine. I have shown here a pictorial view of the Kaplan turbine, where water is collected by the diffuser and then pushed to the runner. When it enters the runner, water becomes axial and then it comes out axially. You can appreciate the impeller looks like a propeller having very fewer blades of aerofoil constructions. I have given you a just pictorial view of the impeller. You appreciate it exactly like a propeller, and you look here at the aerodynamic shape of the impeller, highly twisted blades. This is a Francis turbine, and you realize the flow, this Francis turbine is a mixed flow impaler. And I have shown also the volute casing. Water is collected by the volute casing, and then through the diffuser main it pushed to the runner, where it's neither axial nor radial, and it then comes like that. Please follow my pointer, and it then pushed to the diffuser, a drop tube. Sorry, it is then pushed to the drop tube, and drop tube collect the water and then and pass it to the reservoir. So the volute casing, impaler, and drop tubes complete the vocal systems. Thank you for listening.